Alright, so matrices, day 2 of 2. Solving equations. Isaiah, yeah. Let's keep rolling here. So there's sort of two types, and I don't know how to name them, so I'll just give it as the example here. X, -1, -4, 3, plus 2 times 1, -4, 2y equals 7, -9, 0, 11. Pause for a second and let you get that written down. Now there's two unknowns in there. There's an x. So let's figure out what we need to do to solve for x. And we briefly mentioned this on Friday, I think, but when you're adding matrices, it's very easy to do. You can still use a calculator, but when you're adding matrices, you just add by position. So top left plus top left equals top left. Now we do need to be careful with that 2 there. So in order to find x, let's write the equation, but not a matrix equation. That's a lot to look at. Let's pull out those specific elements. So x plus 2 equals 7. This is pretty easy now. We've got to look at the elements sort of individually here. So x equals 5. The other one we see is there's a y. So let's write an equation with the y. But the y is in the bottom right, so I've got to use all the bottom rights. So that would be 3 plus, again, be careful with the 2 out front. That's really the only thing that people miss, is they forget that there's a 2 out there. 3 plus 2y equals 11. 2y equals 8, and y equals 4. So that's the easy way to solve equations. The easy type of equation to solve, I guess I should say, is you're looking at them piece by piece. That's not most of what we're going to do, but it's part of solving equations. What we're going to do is solve systems of equations. Okay, just got the official word from Miss Morris, so we'll take a side note here to say, yes, the test is on Thursday. Whether you're face-to-face or virtual, it doesn't matter, because everyone's testing on Thursday. There are no block days this week, by the way, so no late arrival Thursday. So for your first period, that means Thursday at 7:25, you'll be ready to go. It is a 50-point test. So that's the bad news, because you'd rather it be a 100-point test, because it's probably not going to be difficult. The good news is it is open note, and open homework, and open warm-up, and whatever you got. Well, I shouldn't say whatever you got. The usual rules, no phones, no Google, no friends, but whatever you've taken notes on, you can use. So a little bit of clarification there for the Thursday test. Bad news, good news, I guess. Still mostly good news. Number 2. All right, back to solving systems of equations. Remember, systems means more than one. And this is a really useful tool, or really useful way to use matrices. So here's a system of equations. X plus y equals 2. 2x minus y equals 15. Now we know how to solve that by hand. You could add those together and get 3x equals 17. And then you get x equals 17 thirds. Then you have to plug in 17 thirds, which would be a real pain. We're going to do this a different way. Let's transform this into a matrix equation. So the first thing we'll do is grab the coefficients of the variables. So 1, 1, 2, and negative 1. So don't grab the x and the y, just grab their coefficients. So 1, 1, 2, and negative 1. So be careful about the signs. You got to include that as the coefficient. The next matrix is the matrix of the variables, which is just x and y. We may do some with x, y, and z, or we will do some with x, y, and z. And then the last matrix, I don't know what to call it other than the answers, 2 and 15. So we've transformed two equations into one equation. I mean, it's a little bit more complicated because it's matrices, but it's just one equation. One matrix times another matrix equals our answer matrix. Here's how we're going to view this. First matrix is going to be A. Second matrix is going to be X. Be careful, that's not a lowercase x, that's an uppercase X. That's a matrix, not just a letter. But it is a matrix of unknowns. It's a matrix of variables. Equals matrix B. Now we're getting close to something we recognize. Because if you had an equation, so ignore all that top stuff. If you had an equation A times X equals B, and you're just trying to solve for X, what would you do? Divide by A, yeah. Now the trick is matrices is you can't divide by matrices. So if I told you you can't divide, but you had an equation that looked like 5x equals 12, and I said no division is allowed, what would you multiply by? I mean, it's the same thing as dividing by 5, but you could multiply by 1/5. You say, you know what, we'll multiply by 1/5, and that will get around your dumb rules about not dividing. Well, it's kind of the same thing here. So there is no division with matrices, but what I can do is multiply both sides by the inverse of A. And just like 1/5 times 5x got us down to just x, A inverse times A times x, well, those would cancel each other out, and we're left with just x. A inverse times B, we could do in the calculator. So if you don't have a calculator, grab one, and we'll put them into the calculator. So matrix A is a 2 by 2. We type in the coefficients, 1, 1, 2, negative 1. And again, double check, because there's not much to mess up except putting them in the calculator wrong. So make sure they're in there correctly. And let's go put in matrix B. If you get confused on the 2 by 1, 1 by 2 thing, then just guess and you'll know right away if it's which one it is. So if you did 1 by 2 first, that doesn't look right. It's got to look correct. So it's a 2 by 1 with 2 and 15. And again, double check, because the calculator's not going to mess anything up. It's only going to be you typing a number wrong. And then I want to do inverse A inverse times B. So matrix A. The inverse button. We did that a little bit on Friday. Go get matrix A. Do it to the inverse. And then times, matrix B. And that's supposed to tell me what X and Y is. You press enter. Oh, I don't like that, but I can change that. So math frac. And there's my X and my Y. Now, I don't want your answer as a matrix, okay? This did not start as a matrix problem. It started as a system of equations problem. So I want your answer to be X comma Y. So you can do two possible answers. You can tell me that X is 17 thirteenths, or 17 thirds, and Y is negative 11 thirds. Or you could do an ordered pair type answers, because we know that that means X comma Y. Thank you. So again, don't answer, or your final answer is not the matrix, because I wanted to know what X and Y are. So you need to answer telling me what X and Y are, like explicitly like this, or you could put it as an ordered pair where we know it's X comma Y. But that's way easier. At least, I don't know if it's way easier for two equations and two unknowns, but it's definitely way easier for a 3x3 type equation. So let's do another one of these. 2x plus y equals 0. By the way, I left some space there because I want this to look nice. Negative 4x minus y minus 3z equals 1. 3x plus y plus 2z equals 2. As far as showing work, I need to see the matrix equation. Okay, so I don't have to see everything, but I want to see the matrix equation set up. So 2, 1. I don't have a z coefficient, or I kind of do have a z coefficient. 0, yeah. If it's 0z, it wouldn't show up. So I can't leave a blank in the matrix, but if I put a 0 there, that would be the same. Negative 4, negative 1, negative 3, 3, 1, 2. So there's my coefficient matrix. X, Y, Z, my variable matrix. 0, 1, 2, my answer matrix. And now it's time to go to the calculator. AXB. So grab your calculator, put that in, do A inverse times B, and then we'll see if we all get the same thing. So matrix A and matrix B are now in my calculator. Now I want to do A inverse times B, but I don't really want to hit all those buttons again, right? Because you got to go get the matrix and then press inverse and then go get the other matrix. So I'm going to scroll back up, and there's what I want to do. I want to do A inverse times B. So I can hit enter on that, and it will bring it back down, and it'll do A inverse times B again, except now A and B are different, so this will give me my right answer. Oh, it's hidden. There we go. So if you remember that, it saves you a little bit of time. Not a ton of time, but makes things a little bit easier. So the matrix X is negative 8, 16, 5. That is not your final answer, though. You need to say X equals Y equals Z equals, or most people will just switch to the ordered pair, or in this case, ordered triple notation. Because if you write it like that, all the math people know that that's x, y, and z. So just about putting it in the calculator correctly. Now, there are some weird things that happen, so we need to talk about Roman numeral 3. Let's see. Now I'm thinking, I'm pausing just to make sure I spell weird right. IE or EI? I think it's IE, isn't it? That's wrong, correct?
IE.
It's IE? Take a vote.
No, that's right.
What I have is right?
That's right.
Okay. I don't know why I just looked weird. Huh. Weird things can happen with matrices. Weird things. So let's try 2x minus y equals 7 and negative 4x plus 2y equals negative 14. Now, we know this one's weird because it's in the weird things category, but generally speaking, we're not going to know ahead of time if it's a weird one or not. So we're just going to work the problem like normal and see what happens. So we'll know when we've got a weird situation here. So back to my matrices. So change matrix A. Change matrix B. Again, always double checking to make sure that you type them in there the right way. And this one's nice because A inverse times B is right there. So I just need to hit it again and it will do A inverse times B again. Uh-oh. And I've got this weird error matrix here. Yeah, if you get an answer, you did something wrong. Singular mat. Singular matrix is what that means. How bad does it get when you ask it to tell you more? Go to. So basically there's something wrong with the inverse. Now, we're not going to get into the details of why the matrix doesn't work, but we need to know that something went goofy here. Can you look at these two lines and see something about those two lines? Let's solve them for y and see what we get. So this one would be y equals 2x minus 7.
Is it equal if one, it's like only one column?
So the other one, let's see if I move the 4x over and then divide by 2. Whoops. What would you say about line A and line B? They're the same line. So if we're looking for where those lines intersect, all the places on the line, or all points on the line. All points on the line are solutions. That's why it couldn't give you an answer, because this was kind of weird. It turned out to be the same line. Now, the extra weird thing, it's like double weirdness going on here, is that's not the only weird thing that can happen. There's another possibility for weirdness. So, last example, and then you can work. Negative 3x plus y equals 5. 9x minus 3y equals 7. So in the interest of time, let's say we put that into the calculator, we get the singular mat statement, meaning something weird is going on. Let's solve them both for y again and see what we get. So that top one's easy. Y equals 3x plus 5. This one, negative 3y equals negative 9x plus 7. Divide by negative 3. Y equals 3x minus 7/3. What would you say about those two lines? Same slope. What does that mean in terms of the graph? What do those lines look like? They're parallel. No intersection. So if we're looking for where they intersect, well, that would be no solutions. They do not intersect ever at all. So the weird solutions, you got to be extra careful. It's not just enough to say, "Oh, that's a weird one, I can throw it out." It's like, no, you have to be more specific. Your answer is either all points on the line or no solutions. And the only way you know is by doing a little bit of algebra by hand to get them to y equals. Because the calculator doesn't tell the difference. The calculator just says, yeah, I can't do that problem. Something weird's going on. And so if you get an error, it doesn't mean you did something wrong. I mean, it might mean that, but it doesn't necessarily mean that. It means you've got to do a little bit of work on your own to figure out what's happening. All right, worksheet 1 and worksheet 2 are kind of working in parallel. Friday we did 1 through 5 on worksheet 1, 1 through 4 on worksheet 2. Today we'll do 6 through 10 on worksheet 1 and 7 through 10 on worksheet 2. By the way, this does mean that on worksheet 2 you can omit 5 and 6. You can omit 5 and 6. They're a little bit weirder. We don't have to worry about them. They're beyond the scope of this class, is a fancy way to say it. Oh, also on worksheet 2, it says solve each system using Gaussian or Gauss-Jordan elimination. No. Solve each system of linear equations using calculator with matrices. There's lots of crazy stuff you can do with matrices that if you're really into math you might learn about later, but we're going to just kind of skimming the surface of what they can do for us. Again, the test on Thursday is open note, including open homework, so make sure you've done it so you got something to refer to.